In this video, we're going to look at declaring, throwing, and catching exceptions. And specifically, we're going to look at method calls and where these things have to be defined. So first, we're going to start with this simple example. We have method 1 that has a try statement and a catch to catch an exception that could be thrown by method 2. So in our try statement, we call method 2. And method 2 is defined as a method, and it has to have throws exception, because whatever code we have in here has the possibility of throwing it. We are required to throw this exception if something happens. So we do a check in there. If some kind of error occurs, we're going to throw that exception. And if that happens, it will get caught by the catch block. So defining a method that throws an exception, I think in general, especially as new programmers, we don't do that as often as we might, because a lot of times we're actually using methods that are built into Java, and those methods already throw the exception. So we do try catch a lot more to catch exceptions that are written into methods that are provided by Java. But if we're writing our own method that could throw an exception, we have to declare it. So the declaration has to be in the method that it throws an exception. A good example that we just saw in a previous video was next int. When we're asking a scanner to get the next int and somebody types in a double, that next int method has a definition that says it throws an exception, and it has code in it that will actually say the word throw and throw that exception. It will create the new exception object and throw it. So the definition has to happen, and then anytime somebody uses that method, they have to do it in a try catch block. There are exceptions to that where we can pass, I call it passing the buck, where we don't have to catch it ourselves, but we'll talk about that later. So every method has to state the types of checked exceptions that it might throw. That's the declaring part. So here's an example of a method we're writing called myMethod, and we're declaring right up front that it throws an IO exception. Sometimes a method could throw multiple different kinds of exceptions. So we declare it this way: public void myMethod, and then keyword throws, and this could throw an IO exception or some other exception. Okay, we can list all the different exceptions separated with a comma that method might throw. Once the program detects an error, the program has to create an instance of an appropriate exception type. So these exceptions are objects. So we have to create the new object, and then we have to throw it. So I always like to think of a baseball analogy when I'm thinking about exceptions. I'm going to create a new ball, and once I have the ball, then I can throw it. I'm creating that object, then I throw it. Something's going to catch it. So this is known as throwing exceptions. So here's an example. We're using the new keyword right here and putting the name of our exception there. So create this new exception object and then throw it. Another way to do that is to do it on two different lines. We can say, hey, we have an exception class that we wrote or that's built into Java. We can say new, create that exception object and assign it to a variable, and then say throw that. So we assign it to the variable EX. EX is an exception object that we created. We can say, hey, throw the object. Here's an example. We have a program for a circle, and we're going to look at that a little bit more later. I'll actually pull it up in NetBeans, and we'll take a look at this program. But it has a method called setRadius of a circle. Okay, and we can set the radius to some kind of double. And the definition for this method says that the method throws an illegal argument exception. Okay, so The throws comes right after the method name, after the closing variable for its parameters. We write throws illegal argument exception, and then the block comes with the code for the method. And so we're doing a little test here. If the new radius is greater than or equal to 0, we assign the new radius to the radius because it's a setter, right? We've done that before. Otherwise, if it was a negative number, we can't have a negative radius, so we throw a new illegal argument exception. Okay, and when we create this illegal argument exception, we can actually give it a message inside this as a argument sent to its parameter. The radius cannot be negative. So we create this new object, and then it gets thrown. Once it gets thrown, the statements, we try and call that method. Some kind of statement happens that could call that method. If the exception gets thrown, it starts going through the catch statements, and we can have multiple catch statements. And we're going to look, is it this kind of exception? If it is, here's the code that handles that. But if it's not that type of exception, let's check to see if it's this type of exception. And if it is, we'll write some code to handle it. And we can continue, we can have multiple catch statements looking for all the different exceptions that could be thrown. And each of them could have different code on how to handle it. Let's take a look at this. Now this can get a little confusing. We're going to look at the call stack. When we call methods, and those methods call methods, and those methods call methods, it gets built up in something called the call stack. So the main method right here, we're calling from the main method, we're calling method 1. So the call stack gets a reference saying, hey, once method 1, we're on method 1, but once it gets done, we'll go back to the main method. And then method 1 calls method 2. And it puts another reference on the call stack for method 2. So that when method 2 completes, it'll go back to method 1. And method 2 will be removed from the call stack. And once we get back to method 1, when it completes, it will be removed from the call stack and we'll go back to the main method. That's how Java keeps track of where it's at with all these method calls. So main method calls method 1. Method 1 calls method 2. Method 2 calls method 3. And you see in each of these that there's a catch. So if something happens when we call method 1, I have a catch over here to process the thing that can happen. If method 1 throws an exception, we'll catch it right here. But in method 1, we're calling method 2. And if method 2 throws an exception, we're going to catch it. So this is catching the exception from method 2. And then method 2 is calling method 3, and if it throws an exception, we're going to catch it here. So what happens when method 3 throws an exception? When method 3 throws an exception, it goes back through the call stack to method 2. It runs the catch. And handles it in method 2. Now, one thing to note that since it happened in method 3, here was the method call. There's another statement that happens after that, right? But the minute the exception is thrown here, it'll never run statement 5. It's just going to run over here and run the catch. Then it'll go on to statement 6. Okay. What happens if the exception over here is an exception of the type that we're looking for in exception 2? If that's the case, it's going to go directly back here. It's not going to find a match here, so it goes back here till it finds a match that does match. Finds exception 2, handles it, statement 4 runs. Statement 3 never does get to run. So the minute something in a try breaks, anything else in the try does not run. It goes immediately to the catch statement that's associated with it. This is basically going through those things that I just went through on the previous slide. All right, so the circle with an exception, I'm going to go through that in the next video. We're going to look at this, an actual real life example in NetBeans. But I do want to mention some other things. Sometimes we can rethrow an exception. In our catch statement, we can do a couple lines and we can rethrow the statement. I call that passing the buck. We have a tries to run some statements, they have an error, it tries to catch them. We can do a little bit of the work here, but then we're going to rethrow the exception. So some previous code that may have called this method, that wherever this is located, that previous code could handle that as well. And there's also a finally clause. We have try, catch, and finally. We haven't really talked about finally yet, but finally runs no matter what happens. In the next couple slides, we're going to trace through a program, and we'll see this. But we have a try, and if the statements here run and they run okay and don't throw an exception, once the try block is done, we have no use for the catch block, so it does not run. But try will run, and then finally will run. So any code we put in the finally block will run if try is successful. If try is not successful, we immediately run the code in catch. And when catch is done, finally will still run. Okay, so finally is a block built into the try catch series that always runs, no matter whether try is successful or try is unsuccessful and catch runs. Finally always runs after those two are finished. So let's trace some program execution. Here we go. We go through a try block and we have some statements. There's no exceptions. If everything runs just fine, the statements in the finally block run, and then we continue on with our program. Let's do another one. Here's a try. We run through. Statement 2 throws an exception. Whatever method we called in here, something threw an exception. Immediately, before anything else happens, if we don't execute statement 3, immediately it comes to the catch block and handles that exception. Once the catch block is done, the statements in the finally block run. So you saw in both cases, whether try worked or it didn't work, finally always runs. And then the program continues. All right, here's one with multiple catch blocks. Okay. Statement 2 throws an exception of type exception 2. So we go down, we actually look at exception 1 and it didn't match. So it goes down to exception 2, handles that exception because this exception matched the kind of exception that was thrown. It threw a type of exception 2. So it went down the list. First one it finds that matches, handles the code, and then we run the finally block. Oh, I missed a section in here. We handled the exception. The finally block runs, and then it throws the exception again. So this was an example of rethrowing an exception so that the calling code that started this whole try catch block can also catch that exception. I didn't see that right away. All right, let's stop this video and I'm going to go to the circle simulation and we'll take a look at that code using some try catch blocks.